Hello everyone, welcome back to another Project Gladiator weather forecast. Today I'll be going over the weather for January 11th of 2024. Starting off with the severe weather outlooks for today, we do have an enhanced risk for the Arklatex region of the United States in southwestern Arkansas, northern Louisiana, northeastern Texas, and southeastern Oklahoma. Threats for today do include a 10% tornado risk with the hashed area, for the possibility of a few strong tornadoes across this region. And the general rule of thumb with that is that if strong tornadoes are going to be supported with the environment, then weak tornadoes are generally expected up to a point. Um, as far as our damaging wind threat, we do have a 30% with a hash area, so we could see the probability of some significant damaging wind gusts as well. And this is going to be a little bit more of a secondary risk alongside our tornado risk. And what the hash area does mean for damaging winds is that we could see the probability of 65 knots or higher of damaging winds. And then we also do have a 15% hail risk with the hash area for the probability of some significant hail, with the probability of hail sizes that could reach 2 inches or larger within that area. As for our future outlooks, our enhanced risk was decreased for the 12th. We aren't expected to see all that much of a tornado risk that was expected earlier in the week. That has been decreased to more of a 5%, but we still do have an enhanced risk, and that has been pushed more so towards the west. It makes a little bit more sense compared to yesterday's day 3 outlook, or earlier today's day 1 or day 2 outlook for this for Friday. So this overall does make a lot more sense as far as the severe thunderstorm outlook, and again, generally just makes significantly more sense, as we do have that enhanced risk backed in northern Mississippi into northwestern Alabama. Threats for this do include a 5% tornado risk, which is going to be a little bit more of the secondary risk for tomorrow. The fairly widespread 5% tornado risk, so we could see the probability of a few tornadoes across this region. 30% damaging wind threat with the probability of wind gusts that could be reaching 65 knots or higher, and a 5% hail risk, so we could see a little bit more of a small probability for some damaging winds, or sorry, some small to medium hail. But overall, tomorrow, we are expected to see the primary risk of some significant damaging wind gusts across northern Mississippi, as well as a secondary risk for a few tornadoes. And then for our day 3 outlook, nothing is issued as far as severe thunderstorms. And then for our day 4 to day 8 outlook, we currently don't have anything issued. Taking a look at our excessive rainfall forecast, for today, we do have a marginal threat that is going to extend from southern Illinois into the Arklatex region, so we could see the probability of some isolated flash flooding in some regions. For tomorrow, for day 2 outlook, we do have a slight risk currently issued for the New England region, for Massachusetts, Rhode Island, Connecticut, the New York City region, as well as northern New Jersey, with a marginal threat that does extend as far south as northern Georgia there, as well as another marginal threat further towards the west, extending from southern Indiana into western Tennessee. And then we also do have a small marginal threat for southwestern Oregon and northwestern California, along the border there for the Pacific Northwest. And then for our day 3 outlook on Saturday, we do have a marginal threat for southern Maine, as well as a marginal threat that is going to extend north of the San Francisco Bay into southwestern Oregon along the Pacific coast there again. And then we can also take a look at our winter weather outlooks for today. We are expected to see quite a bit of heavy snow across the Central Plains into the Midwest region, associated with that significant winter storm that is expected to bring blizzard-like impacts, as well as significant travel hazards across this region. I do recommend that if you know that that you are going to be impacted by this system, that you don't travel at all. Only travel if absolutely necessary. And if you do have to travel in this system, definitely make sure you are taking extreme caution when driving through this. Even if you are taking the necessary precautions for this system while driving, which again, I highly don't recommend. You should definitely stay home if you're going to be impacted by this. But also, you may not know what the other drivers are doing on the road. They may not be necessarily prepared and could potentially be dangerous to you, even if you are staying prepared for the system. Um, we are also expected to see quite a bit of heavy snow for some of the Rocky Mountains there. And then for tomorrow, for day 2 outlook on Friday, we are expected to see quite a bit of heavy snow as that system pushes off into the northeast, with quite a bit of heavy snow expected for the Midwest, as well as some portions of the New England corridor. And then we are also expected to see quite a bit of heavy snow back towards the Rocky Mountains. Then for day 3 outlook on Saturday, we are expected to see quite a bit of heavy snow coming off the Great Lakes, with some of that Great Lake effect snow that is going to be left in the wake of this system, as well as quite a bit of heavy snow for the Rocky Mountains again. And then we may be able to see some heavy snow for northern Oklahoma into parts of Arkansas and southern Kansas. And then we can also take a look at our surface analysis. As of right now, our main feature that is going to be leading to our significant severe thunderstorms in the Arklatex region is still back into New Mexico. So we do have a couple hours until this arrives and uh, pushes into the region of concern. And we are expected to see a little bit of a warm front that is expected to be on the northern side of that warm sector, and that is going to be the main triggering factor for those severe thunderstorms in the Arctic region. Taking a look at our weather models, starting off with our radar omega models, taking a look at the enhanced risk in our jet stream pattern, specifically at our 500 millibars. I'm going to be going extremely in depth on the risk for severe thunderstorms across the Arklatex region. So if you are interested in that sort of thing, please stick around. However, if you aren't interested in the extremely in-depth explanation, I highly suggest you use the timestamps for what you are looking for. Again, those timestamps are in the description for your use. Um, we are expected to see a upper trough here that is expected to push into the Central Plains later tonight and advect into the area of concern. Um, as that shortwave trough that we do see embedded in the flow does round the base of that trough, it is expected to make that trough become negatively tilted as it advects into the region for the classic textbook trough advection as it becomes negatively tilted. And then we are also expected to see the increase of that 500 millibar jet streak. Again, another classic textbook trough advection pattern as that 500 millibar jet streak increases to strengths that are going to be quite strong, upwards of 130, 120 miles per hour, which should definitely lead to elongated hodographs and support the potential for some hail across this region. And you can also see at the 500 millibars, very, very prominent varying of the winds. So we should definitely see quite a bit of directional shear across this region to support the risk for a few tornadoes, some of which could be strong. Taking a look at our 700 millibars and our low-level jet, we are expected to see that low-level jet significantly increase as that shortwave trough rounds the base of that trough and makes it become negatively tilted. Again, classic trough advection, classic trough progression. As it becomes negatively tilted, we do typically see the increase in the strength in the low-level and the mid-level jets, and that is when we typically see the threat for severe thunderstorms is when that becomes a little bit more negatively tilted. So as that does become negatively tilted, we are expected to see the low level jet increase. It isn't expected to increase too much tonight because it is expected to increase wildly tomorrow. However, tonight we are expected to see it become fairly strong, and as it advects into the Arklatex region, we are expected to see it become upwards of 80 to 70 miles per hour as it advects into the region of concern, which should definitely lead to a large curvature in the low levels of the hodograph and definitely really support a ton of directional shear to support the possibility for tornadoes across this region. Hopping back over to pivotal weather for a second, we're going to be taking a look at our 200 millibar upper air maps, so we can get an idea of the defluence and the spreading of the wind vectors, because what that basically does, if you have spreading of those wind vectors and spreading of the isobars, that basically creates a void in the atmosphere, and that that will compensate, the atmosphere will compensate for that void by taking air from the lower and mid levels of the atmosphere, and it will rise upward to fill that void in the upper levels, and that's how you get widespread and strong lift. However, at our 200 millibars, it doesn't really look like we have all that much defluence. It does look like the majority of our wind vectors are going to be staying fairly zonal, with very minuscule spreading of the exit region. So overall, we aren't really expected to see a ton of upper level support as far as lift goes. But we are expected to see a very strong upper level jet, potentially getting upwards of 150 miles per hour, 106 or 150, 160 knots. Sorry, I do have it set to miles per hour on Radar Omega, so that's why I got confused about that. But with the insanely strong upper level maps or upper level winds and our insanely strong 500 millibar winds compared to relatively weak speaking a low level jet, that should definitely lead to elongated photographs and definitely support the possibility for large hail and potentially significant hail across this region. But even if we don't have all that much spreading of the isobars, spreading of the wind vectors, we are seeing a fairly potent setup, especially in our upper air kinematics. So our mid-level and 700 millibars should definitely be able to compensate for the lack of strong upper level support. Again, this is a highly potent setup that we are looking at, and if it did have a little bit more instability tomorrow, and there was a little bit more confidence in the forecast, it could get quite nasty. But because we don't really have all that much instability, and there is an extremely conditional setup tomorrow, we are looking at a little bit more of a lower risk. But if we did have much stronger instability, this type of setup would become quite scary. And then you can also take a look at the geometry of this trough as well. Our cold front, our cold front is expected to be kind of up and down, north to south. And you can see our wind vectors here are somewhat perpendicular. They are fairly perpendicular. They aren't extremely perpendicular to the cold front. However, this should lead to a little bit more of a semi-discrete mode for our storm development. And I will get into why that is going to be a little bit of an issue. Taking a look at our composite reflectivity, not only so we can take a look at the timing for our severe thunderstorms, but also so I can go over some composite reflectivity radar analysis, especially with the possibility of some of those more semi-discrete cells across the Arclitex region, which could become a fairly concerning issue with these storms. Um, we are expected to see our storms become quite robust. Some of those more robust storms amongst some of those more isolated rain showers and more discrete rain showers. We are expected to see those more robust storms begin developing around 9 to 10 p.m. EST. So subtract that by 1 hour, around 8 to 9 p.m. Central Time for this region. Um, we are expected to see those develop rapidly and kind of conjoin a little bit. They are expected to kind of become a little bit of a mess and merge together into this weird line here. With some more semi-discrete cells down to the south of this thing that is expected to develop around 1 a.m. Into the very early morning of tomorrow. And then we are expected to see that cold front start to impinge on the region, as we do see a little bit a broken line, a little bit more discrete systems along that cold front. And then that is expected to push into the Arkansas region around 4 a.m. Tomorrow. Now we can also take a look at some of the radar analysis that I was talking about, mainly with semi-discrete mode that I've been mentioning constantly in the past couple forecasts. So notice how we do have some more isolated storms. You can really notice some of the more robust systems within this event here. And overall, just notice how these storms are kind of separated. They aren't in a line along a boundary, but they are mostly separated from each other. they are still very close together, and we may see quite a bit of cell mergers with this event, but they are going to stay mostly separate from each other. Um, and this is going to become a little bit of an issue because if we do have some of those more discrete supercells, especially further down to the south in the warm sector, they are going to be able to freely use everything that is provided to them in the warm sector, with the instability and the shear. With very little reliance on any frontal systems for initiation, they're going to be primarily driven by warm air advection. And again, they will be able to use everything that's provided to them directly in the warm sector to become quite monstrous. So that's why we have to watch some of these more southern cells that may be in the warm sector, because they are going to be able to freely use whatever instability, moisture, and heat is provided to them in the warm sector. Taking a look at our storm relativity, or in other words, our directional shear, it is the type of shear that is needed to support to support tornadoes across this region. Of course, we do need speed shear to separate the updraft and the downdraft to lead to severe thunderstorms. We need directional shear to support tornadoes. And it does look like we are expected to have a insane amount of directional shear across this region, which is going to be quite concerning because we could see directional shear values that may be getting upwards of 600 to possibly 700 meters squared to second squared, which is very high, and will definitely be able to fuel the possibility of strong tornadoes if we do have instability in place. And because we do have the risk for strong tornadoes, we are definitely expected to have ample instability in place. Our instability, or sorry, our directional shear isn't expected to be as strong as what we are expected to see tomorrow. Um, Whenever we do have the much stronger low-level jet and the much stronger 500 millibar jet streak in the southeast. Um, and again, we are going to have significantly more directional shear tomorrow. We still have very, very strong directional shear in the area of concern for today. Taking a look at our bulk shear at our 0 to 6 kilometers, what this basically takes a look at is it's a combination of our speed shear and our directional shear, but I'm primarily looking at it for our speed shear so we can get an idea of our elongated hodographs and the potential for hail, as well as how our speed shear is going to affect storm organization. So we are expected to see quite a bit of decent bulk shear across this region, upwards of 70 to 60 knots of bulk shear, which should definitely be able to separate the updraft and downdraft of those storms, which will prevent them from cutting each other off and allow for severe thunderstorms across this region. But it should also indicate elongated hodographs and the potential for some hail, some of which could potentially be significant. This is going to be the point where things begin to start getting extremely in depth as far as the forecasting. So we're going to be going very, very in depth on the severe thunderstorm setup for the Arklatex region tonight. So if you aren't really interested in that, I highly suggest you skip to another part of the video. Again, we will have timestamps in the description that you can click for more specific parts of this forecast. If you're interested in that winter storm. But again, we are going to be getting very, very in depth in this portion of the forecast. So taking a look at our dew points and what we are expected to see as far as our moisture content, this is also where some of our uncertainties come into play in the conditionality of this risk. Because of that cold front that did push through earlier in the week, that did lead to some significant impacts across the southeast, the coastal Gulf of Mexico. That did introduce a lot of colder air and a lot of drier air aloft, which is going to potentially become a concern with the quality of moisture return and the quality of heat and instability return to the region of concern. Because of that drier air aloft, it may inhibit some things. However, I'm not really too sure about the dry air aloft. I do believe that we may be able to have a little bit more interaction between a lot of the drier air and the warmer air aloft. However, that may necessarily inhibit our moist layer, as it may not extend further up into the atmosphere as well is what we may like it to. As well as the temperatures, the colder air aloft is going to lead to some stronger lapse rates, and that could potentially help with the mixing of the drier air and the moist air. Um, could lead to some mixing between them, and it could potentially lead to overall increased instability. But overall, I'm not really too certain as far as the forecast with the drier air aloft and the colder air aloft. So we will have to wait, or we will have to watch it. We will have to wait to see how that may affect our storms later tonight. But uh, disregarding that, we are expected to see some low-level moisture values that are going to be getting into the low 60s, which is uh, quite moderate and should definitely provide us with some fairly decent instability if we do have decent temperatures. Taking a look at our temperatures in the warm sector, we are expected to have some fairly decent temperatures. They are a little bit more on the lower side, and they aren't really as high as what we would want them to be. But they are expected to be in the mid to low 60s, which overall isn't really the best for instability. But they are fairly decent and should definitely provide us with some decent and ample instability in the warm sector. Plus, again, as I was mentioning, we are expected to have some lapse rates, which I will show you, and that should help with instability a little bit, and should help boost instability even with these weaker temperatures. Taking a look at our warm air advection, I want to quickly look at where all of this moisture, heat, and instability is coming from. And indicated by our warm air advection here, out of the Gulf of Mexico is where the majority of our moisture and instability is going to be coming from. That is typically how it is. But with this, we are expected to see constant flow of instability and moisture out of the Gulf of Mexico, which may be able to keep instability fairly good, especially at the low levels. Should definitely be able to maintain instability and potentially replenish instability that is lost in the warm sector. And that could potentially also help instability build a little bit, and I'll get into that later. Taking a look at our lapse rates, you can see that we are expected to have some fairly steep lapse rates across this region, with lapse rates that could potentially be getting upwards of 7, which is fairly decent. And this is likely a result of some of the colder air aloft due to the cold front that passed through previously. And overall, lapse rates may be able to help with overall robustity of the updrafts of some of these storms that are going to be in this region, as well as it could potentially help with instability, could help with building instability in the warm sector. Regardless of the how weak and overall lower end our low level temperatures are, so that is going to help with instability, as well as it is going to help with our organization of our storms in this region. Taking a look at our convective inhibition, or our capping inversion, or our sin, either name is fine for it. Basically, what sin does is it's instead of where temperatures decrease with height, they suddenly and rapidly increase with height and then gradually get weaker, and that's what prevents the warm air at the surface from rising freely up into the atmosphere. And the reason we do want a little bit of a cap for severe thunderstorms is because it will allow the instability, heat, and moisture to build underneath that cap until it is eroded away. And when it is eroded away by either by a frontal system or a strong warm air advection, it will explode rapidly, and it will rise rapidly into the atmosphere, and it will overall help with more explosive storms. And as far as the cap is expected to be in the warm sector of our the region of concern, you can see that we are expected to have a quite strong cap across this region, potentially getting up to values of negative 160, which is quite strong for a cap. So by the time that cap is eroded, it should definitely be able to explode quite explosively with a ton of energy in a lot of these storms, and again should definitely help with instability building. However, this overall may lower what we are going to get out of our composite models, such as our energy elasticity index and our significant tornado parameter. So we will have to consolidate for those when we do take a look at those, because they may be a little bit lower in reality than what is expected to happen in a lot of these storms in the real world. Taking a look at our instability, you can see for our most unstable cape, we are expected to have quite a bit of instability, quite a bit of decent instability, upwards of 150, 160 joules per kilogram across the warm sector in the area of concern. This is quite concerning because this is very, very decent and will definitely support the risk for severe thunderstorms. And this will, again, definitely be able to support the risk for severe thunderstorms, as well as the potential for damaging wind gusts, some of which could be strong, the potential for significant hail, as well as the potential for tornadoes, and the potential for some generally weak tornadoes. Um, again, with the amount of directional shear that we are expected to see from the system, which is expected to be quite insanely high, as we did look at earlier, again, this instability is quite concerning because we do have very, very decent instability to fuel the potential for tornadoes. Taking a look at our surface instability, or our 0 to 3 kilometer instability, this does take a look at instability at the very surface level of the atmosphere. And the reason I am taking a look at this, because even if we don't have strong most unstable cape, but we do have strong surface instability, even though we do have strong most unstable cape, don't get me wrong, we do have very, very decent most unstable cape. If we do have strong surface instability, that can significantly help with storm development and significantly fuel those storms. And in certain cold core events, if we have a very strong surface instability, that is typically what we look for instead of a strong most unstable cape, because there won't be strong most unstable cape, but there will be strong surface instability, and that is what generally fuels the tornado risk in a cold core event. So again, even though that this isn't a cold core event, and we do have strong most unstable cape, we are also expected to have very, very strong a very, very decent surface instability, which should definitely be able to help with storm development wildly. Now that we've taken a look at instability and directional shear, we can finally culminate this together into our composite models, starting off with our energy elasticity index values, which does take into account our instability and our directional shear, as well as everything else in the atmosphere to give us the best idea of the tornado risk for tomorrow. Sorry, for today. Um, it does look like we do have some fairly decent energy elasticity index values across its region, upwards of 2 to possibly 3, which is indicative of more of a 5% tornado risk. However, when you do take into account the large amounts of cap in place, and the temperature inversion and how strong it is, it is leading to overall decreased energy elasticity index values than what would possibly be more present in actual reality outside of these computer simulated models. So again, we will have to wait to see whenever storms actually begin developing and how our cap is expected to impact our storms, because I am a little worried that they may potentially inhibit convection a little bit. However, if our storms are able to break through that cap, they should be quite explosive. Taking a look at our significant tornado parameter, what this basically does is it takes into account basically everything in the environment, kind of like energy elasticity index does, but instead of just the general risk for tornadoes, it does give us the idea for significant tornadoes across this region. So you can see that we do have some fairly decent significant tornado parameter values across this region. Overall, this is indicative of a little bit more of a lower-end tornado risk, as I was saying previously. However, again, when you take into account the convective inhibition that is in place across this environment, this is likely lowering our significant tornado parameters quite a bit compared to what is actually expected in the environment in reality. So again, these significant tornado parameter values are probably higher than, or probably lower than what they really should be. And to confirm this, as we do push the model forward into tomorrow, you are seeing this strong, significant tornado parameter values in the southeast, even though we do have a lower end tornado risk, it is significantly higher than what we are seeing today. And this is due to the lack of a cap in this region. We are expected to see pretty much no to a very, very weak cap in the southeast, which is going to allow air to freely rise. So with the lack of a strong cap, unlike today, you can see that we do have a significant increase in the significant tornado parameter values, even though we are expected to see a lower end tornado risk by tomorrow. Taking a look at our wind gust models to see how strong our wind gusts are expected to be for today. With a lot of the storms that we are expected to see in the Arklatex region, we aren't really expected to see all that much of a significant damaging wind threat from those, but we still may see some damaging wind gusts out of those with that 30% region. However, this significant region is a little bit more off balance because it is expected to be associated with the line of storms that is going to be back behind those more discrete cells. And this is expected to be a risk for a little bit more later in the morning or earlier in the morning, early morning tomorrow is what I'm trying to say, as we do have that QLCS, that's kind of quasi QLCS. It isn't expected to be a true QLCS, but it is kind of going to be a broken line of storms, and it is expected to kind of be because a lot of those cells are going to be squashed up along that boundary because of the amount of force that we do have behind that boundary, pushing it forward with such speeds. So again, uh, it is going to be a little bit more of a damaging wind risk for tomorrow and today as well. And this significant region, this hash region, is expected to be continued into tomorrow for northern Mississippi into Alabama. That's why we have this significant hash region for damaging winds. It isn't expected to be associated with any of the supercells that we may see tonight, but it is expected to be associated with that line of storms that is going to be back behind those more discrete cells, leading to that risk for some possibly significant damaging wind gusts. As you can see, they could potentially be quite strong with wind gusts that may be getting upwards of 50, 60 miles per hour, potentially even higher than that. And even ahead of that line, because of the system as a whole, we are expected to see quite a bit of very, very strong damaging wind gusts, not out ahead of that line with some of these storms across Middle Tennessee that could potentially be getting greater than 68 miles per hour. So again, we are expected to see a very, very strong risk for some fairly strong damaging wind gusts tomorrow. And again, that's going to be the primary risk for these severe thunderstorms tomorrow. Switching back over to our 0 to 3 kilometer cape again, I do want to take a look at this potentially hazardous thing that we may see back behind the main line of storms, associated with a little bit more of a localized cold core event behind the main system. We are expected to see again that local cold core setup, and that is expected to bring quite a bit of strong surface instability along with it, as well as with the directional shear that we are expected to see with this trough. We will have to watch the storms that may be across Kentucky, Tennessee, extending down into some of the northern Dixie states for the potential for a low end risk for a brief tornado or two. Taking a look at our total snowfall accumulation, from here on out, I'm going to be taking a look at the significant cold that we are expected to see, as well as the blizzard that we are expected to see impact the United States. This snowstorm is expected to drop a ton of snow. Again, that is going to lead to the possibility of some quite significant travel hazards across the regions affected. However, as far as snow goes, we are expected to see potentially an average of anywhere from 6 to 8 inches in some of the more extreme areas, like eastern Nebraska, southern Iowa, and into northern northwestern Illinois. Again, we are expected to see a ton amount of snow Doesn't look like we are expected to get up to an inch of snow across this region. However, again, we are expected to see a absolutely insane amount of snow across these regions, and again, that is going to lead to some significant travel hazards. And then we can also explain the significant winter storm that is expected to push through the Central Plains and into the Midwest with this as well. Because of the northward advection of this system back into extremely cold air, because we do have extremely strong cold air advection on the back side of this trough, as that trough advects into the north and supports those snowstorms in an extremely cold environment. If it was warm, it would fall down as rain. However, because of how cold it is definitely expected to be a blizzard-like system across that region. So again, that is the primary reason for that significant winter storm. Taking a look at our wind gust models again, I'm gonna take a look at this again because we are expected to see some quite strong damaging wind gusts that may be possible with this blizzard system that we are expected to see blow through the Central Plains and into the Midwest, and this could potentially lead to some impacts as well, as it's gonna blow snow around and potentially drop visibility quite low. We are expected to see wind gusts that could potentially reach the widespread 40-30 miles per hour in the regions affected by this system, with it potentially getting upwards of 50 miles per hour in some regions. And again, that is going to blow snow around and make things hard to see as snow gets lofted. And again, that's generally gonna make things quite hard to see across the regions affected, and is gonna lower visibility significantly. So again, that's why you don't really want to be out on the road because of this. Not only because all the snow is going to be piling up on the roads, but also the strong winds are going to be blowing the snow everywhere and making it extremely hard to see. And then taking a look at our temperatures, I'm going to be going over the extreme cold that we are expected to see today, as well as later on in the week, into early next week, and possibly even into later next week as well. You can see we are already having an insane temperature drop across the northern central plains and the northern northwest. As you can see, we are seeing temperatures that could be getting as low as negative 32 degrees across Montana here, as well as overall just temperatures that are going to be extremely widespread in the negatives here. Almost the entirety of South Dakota and North Dakota is expected to see temperatures that are going to be getting below negative in the overnight into the very early morning of tomorrow, as well as other regions that could see temperatures that are going to be getting not only below freezing but also potentially below zero, is going to be Nebraska, Iowa, and Minnesota, potentially extending down into Kansas. And again, the this extreme cold is expected to expand as the cold front expands back behind the low pressure system that we are expected to see trigger all these significant severe thunderstorms, and that is going to be leading to a very strong cold air advection back behind it. And again, we could potentially see temperatures that are going to be getting below freezing, extend as far south as some of the Dixie states, as well as southern Texas as well. So a very large portion of the United States is expected to see temperatures that are going to be getting below freezing by the end of this week and into next week, as well as a very good portion of the Central Plains, the northern Midwest, the northern Central Plains, and the Northwest, as well as potentially down to the Ohio River Valley, and potentially getting as far south as northern Oklahoma and northern Arkansas, is going to be seeing temperatures that are going to be getting below zero. So again, we are expected to see extreme cold later on this week, as well as into next week, that could potentially become quite hazardous. So if you do live in any of the areas where it is going to be getting extremely cold, definitely make sure you are checking the temperature before you go outside if you have any outside plans. And before you do go outside, definitely make sure you are grabbing a jacket. Now that I've told you the weather, please go down to the description and check out the socials for Project Gladiator and join the Discord for any updates on Project Gladiator. If you live in any of the areas I covered for today, please stay with the alert for the time being. I may potentially be going live later today, depending on plans. I probably will go live. There's a pretty good chance I will to cover this event in the Arklow Arklatex region. Again, if you live in any of the areas, definitely make sure you are staying weather alert. Two other channels I highly suggest you check out are One Nation Weather and Weather Watcher. The links to their channels will be in the description. If you notice anything might have been wrong with this forecast, or you'd like to make a suggestion or ask a question, please leave a comment. I do read them, and hopefully I should be able to see you guys tomorrow with another forecast.